The question that I got wrong on this exam was question 3C. The beginning of this question said, consider a coil of wire that traces out a square centered at the origin in the XY plane, and the coil has N loops, each with current I running through it. The Earth's magnetic field points in the positive Y direction. I began by solving for the magnitude and direction of the magnetic field of the loop at the center of the loop, which is the origin. I then answered the approximate magnetic field of the loop at a point 0, 0, Z, where Z was much greater than D. This was done using the dipole moment of the circular loop. Then for question 3C, it says, a compass is placed to the right of the coil and held such that the compass needle must point in the XY plane. What direction does the compass needle point in? Well, looking at this, we see that the conventional current runs counterclockwise through the loops. In this case, the magnetic field was pointing out of the page in the positive Z direction. Well, based on the right-hand rule, we know that to the right of these loops, the magnetic field pointed into the page, which is in the negative Z direction. The compass is in the XY plane to the right of the loops, at a location where the magnetic field is still pointing into the page. However, the compass is generally affected and moved by magnetic fields that would be in the X or Y direction, since the compass is in the XY plane. In this case, though, the magnetic field is pointing into the page in the negative Z direction. Therefore, the compass is not affected by this magnetic field, and it doesn't move when placed in this magnetic field. It originally pointed north, as a compass needle does, and it did not change, so at the end it still points north. Therefore, the needle direction is in the positive Y direction. As a unit vector, this would be 0, 1, 0.